Oh, hey, look at that. I'm live. Okay, finish up my texting. And what I would like to do today is to go through and talk about this particular paper. Of course, my sister is always the first one to jump online. Hey, Jen. There is a link to this paper in the description of this video. And what I want to do is go through the highlights of this particular paper. It's from Innovations in Practice, and it's called a NASA discovery has current applications in orthopedics, written by Dr. Howard B. Cutler, who looks to be an orthopedic surgeon. Oh, here we go. Dr. Cutler is a private practice, owns Gulf Coast Spine Care and Laser Spine Health. So, yeah. So what I want to do is just kind of go through, because this is something we use on a daily basis. In fact, if I kick this thing on for you, and if I turned that, you can see on the camera that looks like it's purple, but to the naked eye, that's actually red. And if I were to kick the lights off, it's going to get a little bit more intense. And so that's the actual laser that we use. And if we were to change the settings and bring in the LED, it gets much more intense. And we can switch back and forth between blue and red LED now that I'm blind. Anyway, that is the laser, and this is how the laser actually works. So there's a couple things I wanted to talk about from here, some things I wanted to read. First off, let's talk about the abstract. Low-level laser therapy has been actively used for nearly 40 years, during which time it has been known to reduce pain, inflammation, and edema. It also has the ability to promote healing of wounds, including deep tissue and nerves, and prevents tissue damage through cell death. Much of the landmark research was done by NASA, and these studies provided a springboard for many additional basic science studies. Few current clinical studies in orthopedics have been performed, yet only in the past few years of basic science studied outlined the mechanisms of the effects of LLT, or low-level laser therapy, on the cell and subsequently the organism. The article reviews the basic science of LLT, gives the historical perspective and explains how it works, exposes the controversies and complications, and shows the new immediately applicable information in orthopedics. Now, bear in mind, this was written in 2015. So there have been studies that have been done since then. And as the author notes in the second paragraph, he says it may be that there has been much discovered but little appreciated. NASA is continuing to shed some light, no pun intended, on the issue. And in 1993, Quantum Devices out of Barnveld, Wisconsin, developed a light-emitting diode, an LED, for NASA to use in their plant growth experiments. The experiments demonstrated that red LED wavelengths could boost plant cell growth, but coincidentally, the scientist's skin lesions began to heal faster as well. So we put plants in an LED environment, which were the red and blue lights that I showed you. In this case, it was red, and the experiment actually showed the plants grew, but completely coincidentally, they noticed that the researchers who were conducting the experiment, their wounds were healing faster. And that said, hey, we need to do some more research. Dave, nice to see you. I'm here. So they turned it over to NASA, took it a little bit further because they saw immune deficiencies, pituitary insufficiency, and delayed wound healing and muscle and bone atrophy in astronauts, and they wanted to help them with that. So then the paper will go on and talk about the mechanism of action. The second paragraph under mechanism of action is the power of plants. The power plant of cells is located in the mitochondria and are able to produce cellular energy, or adenosine triphosphate, known as ATP, from pyruvate and oxygen. ATP is produced inside of the cell and is literally the cash exchange of the cell. It's literally what gives cells their energy. They notice that when tissues are stressed or ischemic, meaning not getting enough blood flow, mitochondria make their own mitochondrial nitric acid, Nitric acid it actually competes with oxygen and binds to specific enzymes in the cell, and it prevents them from producing energy when those cells are under stress. So the cell gets under stress, the cell produces this mitochondrial nitric oxide, it's nitric oxide, excuse me. And then nitric oxide outcompetes oxygen. The cell cannot produce energy. And what they found was that light energy is absorbed by this enzyme called cytochrome C oxidase, and which triggers several downstream effects. It releases nitric oxide, the good nitric oxide. ATP is increased and oxidative stress is reduced. In other words, the cell has more energy. So when people come into me and they're seeing us for whatever, and I'll use a rib, for example. So this woman comes in, she sees our ad on Facebook, and she comes in and says, well, I've got this pain. This pain is right here, and it hasn't gone away for years, and everything it looked like it was actually a rib that was out of place. So I adjusted her, put the laser on her, and that laser, basically what it did was increase the cellular energy of those cells and got her out of pain very, very quickly. Then there's, let's see, going on, it says there are 4 common targets for low-level laser therapy. Number 1 is the lymph nodes to reduce edema and inflammation. Number 2 is the site of the injury to promote healing and reduce inflammation. Number 3 is the nerves to reduce analgesia or pain. And number 4 are trigger points to reduce muscle spasms. We see all of this here in the office when we use the laser. Just a couple more things to point out here. With over 4,000 basic science research and clinical studies, according to pubmed.gov, and low complication rate, LLT should be considered as a first-line treatment option for conditions such as acute neck or back pain, tendonitis, plantar fasciitis, mild carpal syndrome, and ligamentous sprains and strains. I would add to that osteoarthritis because we see that on a daily basis. He goes on to talk about there are no real known side effects, but it is still considered to be even though it's been around. This is how far behind the times we are, okay? Lasers have been around for 40 years. Research is typically about 17 years behind the times. But even though it's been around for 40 years, insurance companies and Medicare still consider it an experimental therapy, so they'll pay for it, which is ridiculous, but that's another topic for another time. But the conclusion to this paper, it says low-level laser therapy will not replace orthopedic surgery for structural pathology, but it may be useful as an adjunct therapy for patients seeking non-invasive symptomatic treatment or accelerated wound healing. So to wrap up that study for you, this is awesome to come across stuff. But basically, low-level laser therapy, like the Giga laser that you see here, it increases the energy of the cell by reducing. It's absorbed by that cytochrome C oxidase, that enzyme that reduces the mitochondrial nitric oxide. And when you reduce that, they're no longer competing with oxygen. The cell then produces more energy, and the cell has the energy to heal. So that's the study I wanted to share with you. I appreciate you joining me for this short video today. I'm always up for suggestions on topics, but meanwhile, if you have questions, please feel free to reach out, and we will talk to you very soon. Thanks.